Today, I'm going to be walking you through another exciting topic called Permutations and Combinations. This is taken from chapter 2 of the textbook. We're still going to be doing chapter 2 even on Monday because this are 61 pages and there's no way we can finish that today. So it's going to take us all the way to Monday. Like I said, I want to welcome you to my lecture. But before I go into this, I would like to tell you what is the essence of permutations and combinations in real life practical situation. Now, let me start by saying that we live in a world where different things happen in different days. And because of that, we may want to consider possibility for, we are faced with problem of selection. For instance, how do you think is if every player in a team, if every player is good, I want to believe a coach will face a very serious problem of selecting, because I know all players cannot play at a time. Now, I know what is going to be in the mind of the coach is actually to look at the possible numbers of ways players can actually be selected. I want to tell you this is also applicable in election. If three candidates actually, if they are going to compete in an election, and maybe today a new candidate join, the entrance of a new candidate has changed or altered political permutations, because that is actually going to increase the numbers of ways the candidate is actually going to be placed at the end of the day. We need permutations and combinations in real life. And I want to tell you, a lot of people have faced cyber attack. Situation where your PIN or your password is being compromised. Somebody wake up one day and realize that the money in the account is gone. That would be so sad. And the idea of permutation and combination will enable you to generate a very difficult combination of password that would be difficult for any scammer to figure out. It's not as if scammers are intelligent. They are not intelligent, but I also want to tell you they use principle of permutation as well. Okay, so permutations and combination has a lot of applications in real life. Okay, we use them every day. Now I'm going to go into permutation right now. What do I actually mean by permutation? Permutation has to do with the numbers of ways of array of selecting root object from nth object. We have arrow numbers of objects and we have n number of objects in such a way that n is actually going to be greater or equal to r. Okay, in such a way that n can be greater or equal to r. Okay, so in substitution, r is smaller. So we are choosing r from n, but there's a condition here. The condition is that order is very, very important. Okay, so that is what actually distinguishes permutation from combination. I want to tell you the two of them have to do with selection, but the difference between them, why permutations, in permutation, order matters a lot. Okay, the order is very important, but in combination, order is not important. Okay, so in permutation, there's a difference between 1, 2, 3 and 2, 3, 1. Okay, but in combination, there's no difference between them. Okay, so that is what I just want you to see. So take a look at this. I'm going to walk you through an example right now. Give me 1 second. Okay, so take a look at this. We have 8-letter word A, B, C, D, W, X, Y, Z. And how many letters do I have? We have 8 distinct letters. Look at that. There's no repetition, because if there's a repetition, then we're actually going to use a special form of permutation. I just wanted to take pay attention to that situation where letters are not repeated, like A, B, C, D, W, X, Y, Z. What is the possible numbers of ways of choosing all the 8? Okay, in such a way that order is very, very important. So if order is if order is not important, okay, the numbers of way of choosing 8 out of 8 is going to be 1. If order is not important. But if order is important, then it's going to be 8 factorial, or you said 8 permutation 8. Okay, 8 permutation 8 is the same thing as 8 factorial. And what is 8 factorial is actually going to be 8 multiplied by 7 multiplied by 6 up to 1. Now, what is the meaning of 40,322? I mean, 320. The 40,320 is actually the possible numbers of ways of choosing 8 out of 8. But you know what? At the end of the day, it's only 1 out of 4,332 that is actually going to happen. This is just the number of possibilities. Okay, so take a look at that. Okay, now if I now want to generalize, this time around, I'm actually using 8. It could be 4, it could be 6, it could be whatever. So let's call it n. So if we call it n, then if we're choosing all the n, okay, if you're choosing the whole thing, then it's going to be that number factorial. That's why you see n factorial. So which means if I have 7 and I want to choose the whole 7, the possible numbers of ways to do that, if order is very important, is 7 factorial. So that's a formula. Okay, so like I said, I'm going to go into the formula now. We use n factorial in a situation where we are choosing the whole thing. I got 8, and I'm choosing the whole 8. Automatically, that will be 8 factorial. But what if in a situation where I'm not choosing the whole 8, I'm choosing out of that? But I want to believe, soccer team, football team, I want to believe it's not all players that will play at the same time in the match. The coach is actually going to select. We live in a world where we do selection all the time. Okay, so what if in a situation where out of 8, I only want to choose 5, and 5 is less than 8? Then we're going to use the formula of permutation, which we call M permutation P into P in parentheses, and now actually means N permutation R. And what is going to be the formula that we're going to use is going to be N factorial. I'm going to show you the formula right now. So that is the formula, the N factorial divided by N minus R factorial. You don't need to care about that. That's just the derivation of today's. This is what you need. Okay, so you're actually going to use this formula, right? N factorial. Okay, for those, let me see whether they can see that. Okay, so if R is less than N, if the number you want to choose, if you're not choosing the whole thing, okay, then you're going to use this formula right here. Now let us now see whether whether this is reasonable. This is what I actually want us to do. If n equal to R, what if this guy equal to this guy? You know, if n equal to r, it means I'm choosing the whole thing, right? Now let's take a look at this. N minus r is going to be 0. Is 0 factorial is going to be 1. And 1 divided by this, then we have n factorial. You know, I talked about n factorial the other time. You're actually going to use n factorial if you actually want to choose totality, want to choose all the objects. But this is what you're going to use when you are only choosing the fractional parts of the items. So, like I said, that is the formula. We want to go into another example right now. Let me tell you this in assignments, in exam. Oh, okay. Let me quickly address this. Some of you have reached out to me about the lab. And I said, attendance of lab is not important. I mean, it's not compulsory. But if it is not compulsory, why do I curate lab? I curate lab because I look at the nature of the world we're into. Complex problem can easily be conducted using a software. I'm not saying that I'm not going to test your knowledge of the software. I'm not going to test your knowledge of art, whether in assignment or in exam. But if you use that knowledge from me, either in assignment or exam, you're actually going to be graded. But if you decide not to use it, then you are not going to be penalized. Does that make sense to everyone? Okay, so it's optional. Attendance of the lab is optional. And that is why I told my TA to make it, either synchronous or asynchronous, and there is no assignment for lab. But you are doing it to aid your computation. What if you have there are some, as time goes on, we're going to be dealing with some probability distributions. And, some of you, you may not be comfortable using manual way. You may want to use software. Of course, you can use that. But if you don't use that, I'm not going to penalize you. Now, take a look at this question. In exam assignment, you're going to be giving questions. The examiner is not going to tell you whether you're going to use permutation or combination. You're actually going to be the one that will figure that out. But what are you going to see before you can actually conclude the question to be a permutation or combination? I want you to pay attention to this right now. Now, take a look at this question. We have 9 members, 9 club members, and they said, in how many ways can a president, a vice president, and a secretary be choosing from the members of this club? Now, if you look at this question, there is an emphasis on 3 particular members. They are not just choosing 3 out of 9. They are not just choosing anybody, but they actually, if you take a look at a question like this, order is very, very important. In fact, this is in order. The president, the position of the president is actually more than the position of the vice president, and that of the vice president is even more than the secretary. So here, this is a permutation question and not a combination question, because the order is very important here. So here, if you want to answer this question, this is what I need you to tell me. If it is not multiple choice, if it is maybe essay, you're going to tell me, oh, this is a permutation question. And what is the next thing I'm expecting from you? I'm expecting you to write the formula. Don't go directly to this. You need to first write your formula. The formula is actually what I showed you the other time. I'm going to go back. Yeah, this is the formula. You're going to write the formula because the formula will also be graded. Okay, so after the formula, what you need to tell me next is what is your N and what is your R. Your N now, based on this question, is 9, which is the totality of the members in that club, and your R is actually equal to 3. Okay, there you're going to, you're going to plug in what is the value of your N, what is the values of your R into that. And that actually give you 504. Now, what is the meaning of 504? of, we have 504 ways to choose the president, the vice president, and the secretary from a members, of 9. That's what it means. Okay, it is only one out of these 504, okay, that will happen at the end of the day. 504 is just the possibility of what can, the number of possibility of what can happen. Is there anyone who need more clarification on this? Is there anyone? Those of you online, can you also confirm if you're hearing me clearly? Can you confirm if you're hearing me clearly, those of you online?
I can hear you.
Oh, you can hear me. Thank you so much. Okay, so that is for permutation. This is another question. And this question is also a question on permutation. How do I know? Okay, we have 20 raffle tickets in the hearts, and 4 tickets are to be selected. Okay, there's going to be 4 winners. But if you take a look at this, the award is being ordered. Look at that. The order, or the order of the first ticket will win a car, and the second motorcycle, the values of a car is more, car value more than motorcycle, and so on like that. Look at that. So this is also a permutation problem because the order do matter. So here it's going to be 20 permutation 4. Okay, so I'm going to show you now. Take a look at that. 20 permutation 4. You write a formula, then you plug in what is your N and what is your how. Now we are done with this permutation. Then we want to go into a special form of permutation now that we call distinguishable permutations. Okay, what do I mean by distinguishable permutations? Is more or less like, the permutation we just did right now. We did not partition the end object into a component, but the one we want to do now, we first partition the end object into components. And you know what? For instance, if I have 10 balls in a sack, and they are distinguished by colors. Okay, if each of them has a color that is different from one another, then I'm actually going to have 10 colors. It means if I have 10 balls, then the 10 balls can actually be partitioned into 10 groups of colors. That is what it means. In that situation, if I want to find permutation, if I want to find the numbers of way of selecting 10, okay, then looking at that situation, I'm still going to use the conventional formula of permutation, which is just going to be n factorial. Okay, go ahead. Yeah. What happens if different combination of ball, like in this group, you have 5? Okay, good question. We're going there now. We're going to reach there now. Okay. Now I'm going to go there. Yeah. Now, what happened if, look at stuff like this. You have 10 balls and 6 are red, right? 6 are red. And the other 4 each are of different colors. Can somebody tell me how many colors do we have altogether based on what I'm seeing here? Okay. Yeah. Oh, we got 5 extra credits. We got 5 colors. Okay. Now, if I want to solve a problem like this, what am I going to do? Oh, how many balls do I have in total? I got 10, right? That's going to be 10 factorial divided by the factorial of the numbers of red, multiplied by, the remaining 4 have different colors. So what I'm going to have now is going to be 10 factorial divided by 6 factorial, 1 factorial, 1 factorial, 1 factorial, 1 factorial. Okay, so I'm going to have 10 factorial divided by 6 factorial. Then I'm going to have 1 factorial, 1 factorial, 1 factorial, 1 factorial. Okay, so what is now the general formula for that? I'm going to walk you through. Look at that. This is what you're telling me. I need you to focus the board. Hello, can see that, right? The question you asked, take a look at that. you have n objects and n1 of the same kind, n2 of another kind, okay? Now, all what you're going to do is, okay, what is the totality? How many balls do we have? This is going to represent that. And what I have here, okay, it means this is partitioned into n1, n2 up to nk in such a way that if I add n1 to n2 to n up to nk must be equal to n. So this is what we call distinguishable permutations. Okay, so I'm going to give more example on that. Take a look at this. Find the numbers of different ways of placing 15 balls in a row, given that 4 are red, 3 are yellow, 6 are black, and 2 are blue. 10 balls can be partitioned into 4 different colors here. Okay, so what is the totality of the balls? 15, right? Going to write 15 factorial divided by how many red? I got 4 red, going to be 4 factorial. How many yellow? It's going to be 3 factorial. How many black is going to be 6 factorial. And how many blue is going to be 2 factorial. All what I just need to do now is just to compute this. Oh my God, we got 6,306,300 ways. So what we're dealing with right now is what we call distinguishable permutation. Now, I want us to have a real life application of a distinguishable permutation right now. A real life application. The real life application is this. Take a look at what I have right here. We have, give me 1 second. Okay. We have 14 construction workers, and they are to be assigned to 3 different tasks. It means the 14 construction workers will be partitioned into 3 groups. Okay, so take a look at that, and let's look at, let's look at the 3 different tasks they want to perform. 7 workers are needed for mixing cement, 5 for laying brick, and 2 for carrying the bricks to the bricklayers. There's a division of labor here. In how many different ways can the worker be assigned to these tasks? This is going to be a problem, for the for the manager that is assigning workers for work. What if in a situation where workers are equally, equally productive? Then I want to believe, the manager will face a very serious problem of selection. And what he can do is to figure out the possible numbers of arrangements. Okay, so if you want to do that, you're going to use distinguishable permutation. Take a look at that. Okay, there's going to be 14 factorial divided by 7 factorial, 5 factorial, 2 factorial. Oh my God, this guy has 72,072 ways. But you know what? At the end of the day, it is only one way that's going to occur. You know that? It's only one way. These are just possibilities. I'm done with the permutation now, and I want to move into combination. I told you the other time that the difference between them is that the order is important when you are talking about permutation, but the order is not important when you are talking about combination. But the two of them has to do with selection. Okay, now I think I've already mentioned that. I will quickly just go into the formula. Okay, in combination, we don't give regard to order. Okay, so see the symbol now, when you take a look at that guy that I cycled, this guy actually means n combination R. Okay, that's what it means. For permutation, that C, we're actually going to be replaced by P. Okay, now, how can we have a way Let's have an example on combination right now. We got 4 letters, A, B, C, and D. And we want to choose 3 at a time. Okay, in how many ways can we actually choose 3 at a time? In how many ways can we choose 3 at a time? Of course, we're actually going to use combination here if we don't give regard to order. Now, let me tell you this. If you take a look at this question now, I did not mention whether order is important or not. If I silent on that, then it means I don't give regard to order. I'm going to say that again. Take a look at this question now. Okay, the order is not really necessary. Okay, now the 3, the 3 possible ways is going. The possible numbers of way of choosing 3 letters out of A, B, C, D is going to be A, B, C, A, B, D, A, C, D, B, C, D. And something you can notice here, it's just that A, B, C is not repeated. For instance, if you're to use a permutation, you're actually going to have A, B, C, A, C, B, B, C, A, and stuff like that. But another name for this is like, this is like, you don't allow any repetition here. But repetition is allowed when you talk about permutations. Okay, so if I want to ask this same question in permutation, this is what I'm going to have. Oh my God, take a look at that. Can you see what I have? They're going to be a law. This allow repetition. This is when I use permutation, and this is when I use combination. The numbers of ways for the same question with the combination and permutation, that of the combination will be smaller. Okay, so take a look at that. Now the question now is, what is the relationship between permutation and combination? The relationship between, when I divide permutation by R factorial, then it gives me combination formula. When I use R factorial to divide permutation, what I have is actually combination. So therefore, we got a relationship between combination and permutation. Now, this is a formula of combination, n factorial, divided by R factorial into n minus R factorial. Okay, so take a look at that. Okay, I think I've already said the key difference between them is just that in one, order matters, and in the other one, order does not matter. So let's go into an example of combination right now. Take a look at this question. We had this same question before, that we have 9 members of a club, and what are the ways of choosing the president, the vice president, and the secretary? They don't talk about that here. Here is just that, okay, we got 9 members. In how many ways can a committee of 3 be chosen? Okay, you can see that anybody can be chosen here. Okay, so we don't have any regard to order. So here, this is a question on combination. So it's going to be 9 combination, the numbers that you want to choose, 9 combination 3, which I'm going to show you now. Look at that, 9 combination 3. So which is going to be 9 factorial divided by 3 factorial into 9 minus 3 factorial. And what do we have? We got 84. There's something I want you to observe right now. When we solve this question the other time using permutation, the numbers of possible ways we got is expected to be more than this. This is 84 ways right now. Let's see what we got before when we use permutation, so that you'll be able to confirm what I'm talking about. Okay, not this one. Okay, this one. 504. That was what we got when we solved the same question using permutation. You can see the one that have a very huge number is, of course, permutation. And what is the reason? The reason is that permutations allow repetitions. Okay, go ahead. Yeah, the answer for the same question, the result for permutation will be more than that of combination. Why do you want to divide? Okay. You mean the relationship between the permutation and combination? Yeah, yeah. Yeah, that's good. You know, the moment you have permutation, right? No, I think your question is like, if I had used permutation for a combination question, maybe probably I'm just going to divide by R factorial. Is that what you're telling me? Exactly. Yeah. Yeah. Okay. You know, we solved a problem the other time that has to do with raffle draw, right? Where we mentioned what the first is going to get, what the second is going to get, what the third is going to get, and what the fourth is going to get. We want to solve the same question. We want to revisit the same question, but this time around, okay, they did not really mention the order does not really matter. Okay, it's just going to be 20 combination 4. Okay, so just take a look at that. So you're gonna have this 20 combination 4. So that is what you're gonna have. Okay. You know, I'm gonna give you this advice. I will advise, go to the textbook, solve whatever problem that has to do with permutation and combination as an exercise. Just be working on that, because the more questions you solve, the better will be your understanding on this. And I want to tell you, mathematical problem comes in different forms. Okay, so please make sure you grab that and go, solve as many as possible questions. Okay. The next thing that I want to talk about now is what we call the number of subsets in a set. I want to tell you, you've heard about this before, when you were talking about set theory. You have a set. For instance, you have a set that have 2 elements. And what is the possible number of subsets you can have? That is what we call the power of a set. The power of a set is actually 2 raised to power cardinality of a set. This is what give me 1 second. I'm going to use my board right now. Okay, so I'm going to use my board for cardinality, for that. Now, what I'm trying to say, in essence, is that if I have X into A, B, we got 2 elements in this set. For those of you online, if I have set A and it has 2 elements in it, A, B, and we want to find what is the possible number of subsets that we can have. The possible number of subsets we can have is which we call the power of that is 2 raised to power n. And what is n? N is the cardinal number of the set, which is the number of elements in the set. So if I want to get the P of X right now, I said 2 raised to power n. In this case, n equal to 2, because you got 2, right? Now let us now see the subset that we're talking about. We're going to have A, B, AB, and the empty set. I think you remember that, right? So like I said, you're going to have A, B, AB, and the empty set. And that gives you 4, because 2 raised to power 2 is actually going to be equal to 4. In this case, n equal to 2. Okay, so the possible number of subset you're actually going to have is 2 raised to power n. But you know what? There is a connection between combination and the number of subsets of a set. Now, What I want to show right now, give me 1 second. I'm going to bring that down. Okay. Okay, so what I'm going to tell you right now is this. If we have n objects, and if out of n, we want to consider possibility now. You know, I told you 2 raised to power n has been proved to be the possible number of subsets you can have in a set. Now, I want to explain the connection between combination and that. If I have n objects, okay, if I decide, I may decide not to choose. Okay, let me give you this example. Okay, you're doing multiple choice, okay, and you have 4 options. You have 4 options to choose from, okay, and or let me say you have 4 questions in total. Okay, you have 4 questions in total to answer. There's possibility that you don't get any of the 4 correctly. That will be 0 out of, it means you get 0 right out of that question. Another possibility, you get 1 correctly, you get 2 correctly, or you get all the question correctly. This is a possible number of events that can happen, right? I want to tell you, mathematically speaking, when I add this combination to this combination to the last combination, it will automatically give us the same value as a formula to figure out the power of a set. So that has been proved to be equal to that. So in a question where instead of you to use this, if you use 2 raised to power n, you are fine. Okay, if you use 2 raised to power n, you are fine. Okay, let us now apply that. Oh my God, pizza! I love pizza a lot. Okay, let's look at that. A pizza parlor offers the basic cheese pizza and a choice of 16 toppings. How many different kind of pizzas can be ordered at this pizza parlor? How many? You know, we're talking about the idea of the number of possible subset will actually be used here. Okay. Oh, go ahead. You want to ask a question? Yeah, go ahead. Oh, are you trying to provide a solution? Are you talking about this one? Oh, okay. Okay. So what are you trying to say? Oh, you said 2 raised to the power of 16, right? Oh, I mean, I'm going to give you extra credit for that. If you don't want to say 2 raised to the power of 16, if you want to use in a combination way, do you know you're going to waste your time by saying 16 combination 0 plus 16 combination 1? You start going all the way to 16 combination 16. That is going to take forever. So why can't we simply write 2 raised to the power 16, just like what you said? Send a message to me for extra credit. Okay, now take a look at this now. On a normal ground, that is a combination question, but we have a way around it. You know, we find ourselves in a world, if we can get a simpler formula around, why do I need to worry myself applying a highly complicated formula? Because we need our answer on time. When there's a problem, we want to take decision on time. We don't want to be overwhelmed by the problem, okay? And that is why we need to have a simpler way to do that. Okay, so 2 raised to the power 16, we actually do the job. Okay, and what I'm trying to talk about now is that if you also do 16 combination 0 plus 16 combination 1 plus 16 combination 2, all the way to 16 combination 16, that is going to waste a lot of time. But the fact that 2 raised to the power n is the same thing as n combination 0 plus n combination 1 up to n combination n, that would be fantastic. I don't want to rush you. I'm actually going to stop here today. And I'm going to start from here on Monday. Like I said, we're still going to use this material on Monday. So we're still continue chapter 2 on Monday. Make sure you stay safe and have a lovely weekend. You're welcome. Those of you online, is there anyone want to ask question or only clarification online? Okay, you guys are good, right?
Yep, thank you.
You're welcome.
Thank you so much.
You're welcome. Yep. Oh, okay. Okay, okay. Yeah. Yeah, let me just do some pack up. You're welcome. Yeah.